Okay, hello, my name is Max. We're working on discussion 10 of Spring 2015 CS61A, and I'm going to give a quick review of generators, which are a pretty confusing topic in CS61A. Okay, so generators are sort of this shorthand method for constructing iterators. And a generator is going to be some function is going to be created by some function that contains the yield keyword. So this is an example of a super basic generator. This generator is what's going to happen when I call this generator with no arguments is Python is going to look and see that it finds a yield keyword in here. And so instead of executing the code inside of countup, what it's going to do is it's simply going to return out a generator object. So it's going to assign this to gen1, and now if I call gen1, I'm going to get a generator object. It's going to say and it's going to give me some memory location or whatever. Okay. And this generator object is actually pretty cool. It's an implicit iterator, so it actually already contains the next keyword or the next method built into it. And when I actually call next on my generator, what's going to happen is the first time I call it, it's going to start at the top here. It's going to set some local variable current equal to 0, and then it's going to enter this while true loop. And when it hits this yield keyword, it's actually going to pause execution of my frame. So I've sort of constructed, remember in our environment diagrams, I'm going to construct some frame. I'll call this something like frame, this will be like frame 1, right? And it's a call to count up. And we've got a current, and it's equal to 0. Okay, and so when I first call next generator 1, I'm going to start here, go down here. When I hit this yield keyword, I'm going to pause execution of this function, and I'm going to spit out this value current, and so I'm going to get a 0 out. And I'm going to keep this frame around. So when I return normally in Python, what I can do with this frame is just sort of get rid of it, because I'm done with all of the contents in it. I'm never going to look at this frame again. But this yield keyword instead signals to Python, okay, I'm going to actually come back to this frame at some point. So just keep all my local state as is, and just spit out some value. And in this case, we're spitting out current. Okay. And it's actually it's going to stop right here. So we haven't executed this current plus 1 yet. Now when I call next again on my gen1, I'm going to resume where my yield left off. So I'm going to resume right here. And then I'm going to begin executing until I hit yield again. So I'm going to increment current. My current is going to be equal to 1. And now since I'm in this while true loop, I'm going to go back to the top, check the predicate. The predicate is always going to be true because it's just true. And then I'm going to execute this yield statement again, pause execution right here, and I'm just going to spit out this 1. Okay, now if I call next again, I'm going to get 2, and so on and so forth. Right? You can sort of see the pattern here. And this is just going to keep going forever. Okay, so this is a quick introduction to generators, and they're super useful and very cool, and yeah, okay, great. If you have any comments or concerns or questions, just leave a follow-up right after this. Wait a second, no. Okay, so now that we know a little bit more about generators, let's actually build a generator that's a little more complicated than this right here. We're asked to build a generator to calculate a sequence of perfect squares. So perfect squares are 1, 4, 9, 16, etc. So let's build a generator to do that. I'm going to define perfect squares. And I'm going to keep track of some state here. So I'm going to keep track of some current. And I'm going to set it initially equal to 1. Because I want to, and I know I'm going to return current times current squared, right? If this was just return the first call to perfect squares, then it would just be return current squared. And so I'm going to, since my perfect squares are an infinite sequence, I'm going to say while true here. And I'm going to yield current times 2, and then I'm going to increment current. Okay, so a few things about this. One is, this is going to execute forever. If I instead didn't want this to execute forever, I could do one of two things. I could either have some condition in here that checks to see whether or not current is equal to a stop value. So say I only wanted to print the first 10 currents. What I could do is somewhere down here I could say if current equals 9, I could explicitly raise a stop iteration. And now a call to next is going to reach this stop iteration, and I'm going to, and my iteration is going to stop. And so it's going to do exactly what we had in iterators before, sort of explicitly tell the next method that we're done iterating and there are no more values left in the sequence. Another way to do this is I could actually just put a return in here. So I could say, instead of having raise stop iteration, I could have had a return where what I just erased. Or I could, instead of having while true, I could do something like while current less than or equal to 10. And once this is no longer true, it's not going to re-hit this yield statement. It's going to hit a return by walking off the edge of the function. It's going to hit a return none, right? And what that signals as well to my next is that I'm finished, my calls to next, that I'm finished with my iteration. So those are the two ways that I can sort of put some sort of check to see when my sequence is finished inside of a generator function. So, okay, so we talked about two. One is stop iteration. One is explicitly just calling return. And both of those are going to work. Okay, if you have any questions, comments, or concerns, please leave a post on Piazza or on YouTube, and we'll get them answered as soon as we can.